Section 2. What is an algorithm? Learning objectives. By the end of this section, learners will be able to define algorithm in clear, simple terms. 2. Relate algorithms to everyday analogies. Cooking, directions, math. 3. Recognize the role of algorithms in computers and AI. 4. Understand why algorithms are the basis of all AI systems. Before we can talk about artificial intelligence, we need to grasp one key concept, the algorithm. What is an algorithm? An algorithm is simply a set of rules or step-by-step instructions to solve a problem or complete a task. Think of it like a recipe in cooking. Step 1. Chop onions. Step 2. Heat the pan. Step 3. Add oil, fry onions until golden. Step 4. Add spices and vegetables. That's an algorithm. It takes an input, the ingredients, follows steps, the method, and produces an output, a finished dish. Everyday analogies. Algorithms are everywhere in our daily life, even outside computers. GPS directions. Your navigation app gives you the shortest route. Step 1. Turn right. Step 2. Go 500 meters. Step 3. Merge left. Final output. You arrive at your destination. Math problems. Long division is an algorithm. Input, numbers. Steps, divide, multiply, subtract, repeat. Output, final quotient. Getting ready for school. Step 1. Wake up. Step 2. Brush teeth. Step 3. Get dressed. Step 4. Leave for bus stop. That's a personal routine algorithm. The key thing? Algorithms are structured, repeatable, and goal-oriented. Algorithms in computers. When we shift into computers, algorithms become precise digital instructions. Computers don't understand like humans. They follow algorithms. An algorithm tells a program exactly how to handle data. Example. Sorting. A computer arranges a list of names alphabetically by following an algorithm. Searching. Google uses search algorithms to scan billions of pages and rank the most relevant results. Algorithms in AI. Now, in artificial intelligence, algorithms are applied at a different scale. Instead of just sorting numbers or following GPS directions, AI algorithms process massive amounts of data, look for patterns, and make predictions or decisions. Examples. An algorithm behind a spam filter sorts emails as spam versus not spam. An algorithm behind Netflix recommends a movie by matching your viewing history with others. An algorithm behind voice assistants translates sound waves into text and responses. In AI, algorithms are like the engine. They take in huge data sets, follow logic, and generate useful outputs. Why this matters understanding. What is an algorithm matters because it shows AI is not magic, but built on structured instructions. It gives you the power to explain AI clearly to others. It connects everyday life with AI applications, making learning relatable. Reflection. Think of a daily activity you do regularly, like making tea, packing for school, or brushing teeth. Could you break it into a step-by-step algorithm? How is that process similar to how computers follow instructions? Key takeaways. 1. An algorithm echoes step-by-step instructions to complete a task or solve a problem. 2. Everyday analogies. Cooking recipes, math formulas, GPS routes. 3. In computers, algorithms are precise rules that handle data and automate processes. 4. In AI, algorithms scale up, finding patterns in huge datasets, powering tools like spam filters, recommenders, and voice assistants. 5. AI is not magic. It's simply algorithms plus data plus problem solving.